Welcome to another NUCIDA video. If you like it, please give this video a thumbs up, subscribe to this channel, and click the bell. Never forget our upcoming sessions. If you have any questions or hints, please leave a comment. Our certified QA experts will reply in time. It's never been easier to manage tests at scale than with Xray Test Management. Xray is a JIRA native software test management app that ensures your testing and development teams are collaborating to achieve the highest quality products. With Xray, you'll never deliver broken or untested code again. Xray is a comprehensive test management solution that uses JIRA native issue types to specify, organize, plan, and execute tests. With Xray, you can create your tests and add preconditions, organize them using the test sets or the test repository, plan your test strategy, and finally execute tests and report the status. In this video, I show you how you can bring your software testing with Xray integrating test automation and a CI/CD pipeline to the next level. So next, let's see how all of this looks like with an example of a Playwright test. Before jumping into the demo, let's take a closer look at how Playwright can be used for UI testing, while seamlessly integrating with Xray to enhance traceability and reporting. In this example, we'll see how we will test web applications with two tests, one that will log in with valid credentials and one with invalid credentials. But let me just highlight that we have contributed to a reporter on Playwright, which allows you to include more rich information in the reports. Namely, you can have test keys where that will link the automation and the execution of the automation to a test in Xray. So, you can define a test key on the test info annotations. You can redefine the summary of that test. You can also rewrite or define a description that is most suited for these tests. You can also link that test to a requirement, or even add attachments like files in Base64. This will allow you to increase the information that you can pass into Xray. Let's jump to the demo of a Playwright test. In the JIRA instance, I have Xray activated and I'm going to push the Playwright tests. Here, we have the requirements. A user story xt41 that is already being covered by 4 tests. When you activate Xray, you will see this new section, the test coverage section, which shows you all the tests that meet your requirements. You will also see the overall status result calculated over all the executions of the tests that you have linked to this user story. This means that the user story or requirement is not okay now, which means that at least one test concerning successful login is failing. Regarding the code in this test login.spec.js, we have 2 tests that define a login with valid credentials and a login with invalid credentials. To achieve this test, we have created a login page to follow the page object model where we define an object for a page, and we have all of the operation of that page defined in here. This will allow us to divide what is the aspect of the page from what we want to achieve, meaning that 1. I want to do the login. 2. The login is achieved with these 3 steps. 3. At the test level, I'm just going to say do a login on this page. 4. It will perform these 3 steps. If for any reason, in the future this will not be true. If we need an extra step, if we need less of a step to do the login, the test itself will not change. Thus, less maintenance, and what will change is this page object that we need to change, and just have here the changes on the page. Coming back to the test, this means that we are loading the login page, we will navigate to it, we will log in with this login and password, we'll get the inner text, and we'll validate that. This is what we expect. The message is expected after the operation. What changes from a normal test? The Playwright test has some specific annotations because we are using the Xray Reporter that I just referenced before. This will allow you to add specific information to the JUnit file to enable you to enrich what you want to pass to Xray. Here, we see that we are linking this test to this test in Xray. We are defining the test summary and linking it to a specific requirement that I just showed you. We are defining a new test description. Concerning our second test login with invalid credentials, we will do the same, but with an invalid password. Here, we will validate the message that now the login failed with an invalid username and password. The properties are the same. I'm just linking it to a different test to be categorized differently. In this test, I'm also having a screenshot on the report. To configure the reporter, you have to go to the Playwright configuration in this area, and you will see that we are not using the default reporter, the HTML one, but we are using the Xray app Playwright JUnit reporter with this set of options that are also defined here on the same file. The Xray options will allow you to customize a little bit of what you want to have on the test result file. In here, I'm just saying that I'm going to embed the annotations as properties and the test. The text that will contain annotations, the test description, and the embedded attachments like the test run evidence. Another important thing is the project configuration. Playwright enables you to define projects that will allow you to run your tests targeting a specific browser. And you will see that on the command line, I'm going to define which browser should be used. If I don't refer to any browser, it will execute the tests for each one of the browsers defined in this project. Coming back to the test, what's missing is executing. To execute that, we can use npm test that will execute this command. That is exactly what we use to execute the Playwright tests. These commands just say that I'm going to produce a report called Xray Report.xml. I'm going to execute npc Playwright tests, which means executing all the tests that I have here. But for Project Chromium, by default, this will execute a Chrome browser in Atlas mode to execute the tests. Let's try it out on the terminal. I'm just going to put npm test, and this will start the tests. As we see, 2 tests have passed, and in the report, we will see that we have all the details for each test. We can see the extra properties being added. So we have the test key that we are going to link, the new summary, the requirement, and the test description. In the first test, we didn't have any test run evidence, but in the second one, the evidence is a screenshot that we are taking. All this information will be ingested into Xray so that we can see those kinds of details directly in JIRA. What's missing is importing this to Xray. To do so, I'm going to use a command to do the authentication. First, it's about getting a valid token. To do so, I'm going to invoke the authentication endpoint of the API of Xray with a file called Cloud Authorization JSON that I have pre-prepared. It's just a JSON file with the API key, and the secret that I need to provide to the API for it to return a valid token for me to use on the next requests. So, performing the requests, the API will answer back with the token that I have saved in this variable, and now I can just push the result into Xray. The results into Xray, I'm going to say that I'm going to push content type text XML to a post request with an authorization token bearer using the token that I just extracted. The data that I'm going to push to Xray is the file generated, the Xray Report.xml, and I'm going to push to the JUnit endpoint because this is a JUnit test result. I'm going to say, well, the project is XT, and this is for the test environment Chrome. Once I push this, it will push the Xray report to Xray, and Xray will validate if the tests already exist on the Xray side. If they exist, they will just link the new test execution to it. If they don't exist, they will create the test and link the test execution. Test execution is now XT764, so if I come back to XT41 and reload, we will see that now we have a new execution with new results. So, the test curve will just change instead of the failing one, because we have re-executed the 2 tests and both are passed now. Thus, the overall result calculated is okay. This is good news for this requirement. Everything is okay, and if you want to check more details, we can jump to the tests that will have the test execution there, where we can see the details that we have pushed into Xray. The test execution XT764 has new objects created on Xray, including all the test runs that are associated with. We have a successful login and an unsuccessful login. I'm going to open the unsuccessful login just to show you the evidence that we are pushing also. And in here, we can see that the successful login does not have many details because when it's a success, we don't have log stack traces or anything, but we are pushing a screenshot. If I press here, we can see the screenshot that we have taken for this test, and we have all the details also defined. And as you can see, the test environment that I've passed as Chrome is also set. So now we have more information to filter out different types of tests that we may have here. This concludes with the Playwright demonstration. We are now going to move forward with the performance tests. The performance tests we have prepared are Locust tests. As you know, performance tests are not deterministic. They cannot be evaluated with a pass or fail result. So we are approaching it with a KPI-based assessment. We measure success with 3 key performance indicators: requests per second or RPS to ensure load capacity, the 90th percentile response time to check the speed of the majority of the requests, and error rate to detect failures during execution. We have defined a listener that will convert those metrics into KPI results and create an Xray JSON result file that can be ingested by Xray. Finally, let's look at the code example. Here we define KPIs for specific endpoints like logging, reservation, and purchase. Each has thresholds for response time less than 5 milliseconds at the 90th percentile RPS, which should exceed 500, and an error rate that must remain 0. If any of those thresholds are breached, errors are triggered in the pipeline. In summary, this approach seamlessly embeds performance testing into Xray, ensuring that we catch and address issues early for reliable deployments. Let's now jump to the local demo. Before jumping into the code, let me just show you the test plan I have created in Xray to hold the tests regarding performance. Test plans are ways or objects that you can use in Xray that will allow you to plan your executions, and in this case, I'm going to gather all the performance results under the same test plan where I can analyze the performance impacts on my application. Here, I have created 3 tests that will hold the results of the KPIs that I have defined in Locust. In the code, we have a Locust script that is a Python script, and with Locust, we define tasks that are the journeys we want to define or the endpoints we want to exercise with the performance tests. And in here, I'm going to exercise the login endpoints, the reserve endpoint, and the purchase endpoint, and pass some values to those endpoints to do some actions. The actual Locust test will use the task that I've defined above, targeting this endpoint, and adding a listener here that will serve the tests to define what the KPIs I want for each one of the endpoints are. In this case, those 3 KPIs are response time, RPS, and error rates with values for each one of the endpoints. This is meant to add this KPI listener as a new listener for Locust, and this listener is a class that I added that will calculate all the metrics that are gathered by Locusts, which are usually a lot of files. Like we can see here, we have statistics, statistic history, failures, and exceptions that are full of values of page loads, the time it takes, how many requests are executed, and all of that are metrics that are gathered by Locust. But I want to convert that into 3 KPIs, and I want to link those 3 KPIs to 3 tests. So here are the keys, and in this class, we will see that calculations are done to calculate the RPS and the fail rate regarding the metrics that are passing. I'm going to also check the metrics each time a value or threshold is not validated or is over the value that we are expecting. I'm going to add information to the Xray result JSON file. This method will do exactly that. So each time something fails on the log error, I'm going to do the same append with a failed status. If it's not failed, I'm going to add a pass status. And here, you can customize as you want for your type of result and change things. But the important thing is, I'm creating an Xray JSON result file in this file where I'm just saying how it is structured. It should be compliant with what Xray is expecting. All of these definitions of the format are present in the documentation if you want to implement your own. So now what's missing is executing the executor commands. What we will see is, well, we are going to use Locust. So Locust receives a file that is my Locust script Python. I'm saying that I'm going to run this in Atlas mode. I'm going to use 10 users, and I'm going to start with 1 user and increase 1 user each second for the amount of time of 1 minute. All the CSV files will have a prefix on the name called example. That's why we see example underscore and the rest of the file. Once I press enter, Locust will start. Let me just scroll down this a little bit. It will start. Then you will have output in the console for all of the tests that it is doing and all of the increments of the user that it is doing. We can see here it will ramp up 10 users at the rate of 1 per second. And we can see here the number of requests increasing as the number of users also increases. Now the Locust script has finished. We can see the rhythm of what was done here. We can see all the files. Let me change this. All the files with the statistics that it has recovered, the history of the statistics, all the failures and all the exceptions that it has gathered. I also generated the Xray results JSON file with all the information of the test that has just been executed and the values for each one of the KPIs that I have defined. So now to import this into Xray, I'm going to use an API call to the endpoint. I'm saying that the content type now is JSON because I'm going to pass the Xray results JSON file, and I'm going to use the token that we have extracted before for the authorization, and I'm going to use the endpoint of Xray JSON. Once I press enter, the API will receive the Xray JSON file and will create a new execution with the results of these tests. The new execution is XT763. Jumping back to the test plan and reloading the page, I will see now that the results are here. The overall status has not changed because the tests have the same results. They are consistent. But on the test execution, we will see that we have XT763, which is exactly the one that has just been created. And if I jump into the test execution, I will have all the details for each test that was executed as we can see here. If I want to know the details, for example, of the error rate, I can see that this one has failed. I have all the details that were added to the Xray JSON file with the errors for each one of the endpoints and why it failed, and all the CSV with metrics that were added to the file. Just to finalize, let me just tell you that the API does a lot more than just importing execution results. It allows you to do the authentication like I showed you, but also it will allow you to export Cucumber tests. Here, it has to do with how you want to work with the Cucumber workflow. We explain this in more detail in our video tutorials here on this channel, so please check that out. You can export the data sets that are defined in the manual tests. You can import execution results, and this is what I've just shown you here with Playwright and Locust imports. You can import tests. This is usually used when you are shifting from another test management platform, where you export the tests from that platform and import them into Xray. It needs to be in a specific format, but it's fairly easy to do. You can also import custom tests, and then you can work with backup and attachments. So, in a nutshell, the Xray API will allow you to do a lot of other things in Xray. Then we will jump into GitHub Actions. I have just one demo that I'm going to go over, I think almost the last one. So, remember that we have several plugins, more than just the API available plugins. This is not a plugin, it's an action that is available for GitHub. Now we have an action that will allow, instead of calling those HTTP requests to the API, to encapsulate them in an action. This action will allow you to define the username and password if you are using the DCO server version. If you are using the cloud version, this will be the API token and secret. It allows you to define if you're using Xray Cloud or not, what the test format is, and it supports all of the formats that Xray supports. So, XUnit, JUnit, and all of those. What is the file that we will import? And if you want to associate it with a test plan and a project, you can also have it here. The only thing when you are using it is, for those who have some experience on GitHub, make sure that this action is always called. Why? Because if the test fails, the pipeline will fail. And if by default it fails at the step where it had failed, then the results are not ingested into Xray. You must make sure that this action will always be executed, unless, of course, the tests are not executed. If the tests are not executed, we don't have the results to ingest. But if the tests have failed, you need to ingest those into Xray to have that visibility also. So let me show you what it looks like on GitHub. On GitHub, we have several tutorials with code. This is the one I just talked about, Playwright, just to show how the actions are done. As you can see, we have here all the information and links to the tutorials in the documentation that will explain this to you. For those who are not familiar with GitHub, GitHub will allow you to have a set of actions that you can define to do several things. One of those is to compile and execute tests. I have defined this YAML file, which is the file that will define everything that I have for the test execution. In this file, I'm defining that I'm going to use Node.js. I'm saying that this is Node.js CI, and I'm going to extract the branches associated with this action. I'm going to run on Ubuntu at the latest. I'm saying that I'm going to use two node versions, 14.x and 15.x. This is useful to keep track of if the code continues to work on both versions. I'm going to check out the code and then execute an npm install to install all the dependencies. I'm going to use the same commands to run the Playwright tests, and then here is the GitHub action that will import the results to Xray. As I said, I have created secrets here on GitHub to define the username and password. I'm saying that this will be to cloud the base URL of the JIRA instance, which is also defined in the secrets. I'm saying that I'm going to use JUnit. The results are generated in xrayreport.xml, and I'm passing the test plan and test project key also in the secrets to being associated with the right test plan and test project key. And I'm also setting the node version as an environment to Xray. What this looks like, this usually should be triggered by a new commit or a change in the code. But as I'm not going to do that, I'm just forcing it to rerun, and I'm going to say yes, rerun all the jobs. What this will do is take the definition that I have put there and just show me. And we can see what's happening in each one of those steps that we are defining. Installing everything that is needed for Playwright, then executing the tests. As you can see, 2 tests using 1 worker login validations are being executed, and it should be fast for us to have some feedback over it. Basically, this is useful when we have pipelines in GitHub or pipelines in other CI/CD tools to have the results automatically ingested into Xray. As you can see, these are the import results to Xray. We have here information that we are passing, well minus the secret that I hid, and I'm glad that they are. And the feedback is, well, this was imported, and the execution is xt761. If I go to Xray to open it, xt761 is the test execution that was generated by GitHub Actions. As we can see, we have here the 2 tests, and we can see details of the execution. In the same way we're using the API on our local machine, we can use GitHub Actions, taking plugins or other plugins we have available, or all the API calls elsewhere. And it will do everything that we have just said. And we have also said, well, the test environment we are using is Node 15.x. That is the one that we have defined on the GitHub Actions. This was pretty much it regarding demonstrations. I hope it was helpful because sometimes we think of test management tools, and we forget what else they can bring to the table in terms of visibility and centralizing of information. This is pretty much game-changing in how we approach quality in our teams. But to close the loop, what's missing is reporting, because now that we have all the information centralized in one place, reporting can be valuable and game-changing also. So, out of the box, Xray has several reports available to you. We have the overall coverage report that I'm going to show you in a little bit. That is this one that will allow you to analyze in terms of requirement coverage, how your project looks, and what's going on in that project. We have the traceability report displayed on the second image, allowing you to trace back and forth all the activities that you have been doing. You can trace from the epic to the user story to the test that is covering it. For example, you can understand that Bugstore 18 has been created in this test execution that is from this test, that is covering this user story and impacting this epic. So you have this traceability visibility that allows you to know where those problems are coming from, or just to analyze what is linked to what. You also can check the test plan list. This will give you a list of all the test plans that are being used in your project and their status. This information is helpful, and of course all these reports are also available as gadgets for you to create your dashboards with several gadgets to customize the experience or the information that you want to show to different teams. Let me show you what it looks like. Xray has all these options here in terms of reports. They're all centralized here. Now we jump to the test coverage one. Here you can generate a report for a specific project. You can define how you want to see it. I'm going to focus on the priority, and I'm going to use the latest statuses. Then I press generate, and immediately I have a view of everything that's happening in my project. I have divided this view into priorities. And for each one of these, it's easy to understand what's happening just by looking at this. I will say, well, no, we still have failing tests for medium priority. We even have some requirements that have no tests defined to cover them. What's happening here? We need to check this. And for the failing ones, I can jump directly to here and see what the failed tests are and do a further analysis over it. This is a powerful report that will give you a clear view of your project. The other one that I just talked about is traceability. This will give you the same thing. So, you choose the project's final status. I'm going to generate the report. This will give you a view of everything that's happening on your project. And this can be long, but let's say that I want to see only the not okay statuses. This will allow me to filter out the rest to do a better analysis of what's happening. Finally, the test plan metrics. We have a lot of other reports here that you can explore on your own, but nevertheless, on the test plans, you can see all the test plans. You have the tests gathered by status, where you can see how many you have of each. You can see how many test executions, and jump directly to those, how many test runs, and how many tests you have associated with this test plan. And you have tests by test type. So, this means that the 11 tests here are all generic. Here, for instance, we see that this test plan has 4 manual tests. All valuable information for you to manage quality in your projects. Here is a custom dashboard that I've created that has the different reports represented in various ways for me to provide information to my team. Here we have the best execution list to understand what is being executed. I can see how many tests we have per type. We have 102 manual tests. Is this good? Is this bad? Should this be shrinking or not? All these questions are healthy questions to ask. We have the coverage going on, divided by components. I can analyze through components what's going on, and all a series of different valuable information that is helpful not only to share what's happening in your project, but to share in ways that mean something for the person that you are targeting this report to. You can customize it with the correct dashboards, and you can combine Xray gadgets with JIRA gadgets to have a better view of the project, and not only of the quality. Test management shouldn't be a burden to your team. That's why over 10 million testers and 10,000 companies in 135 countries worldwide trust Xray to deliver the highest quality products faster than ever before. Break the silo between testing and development. Integrate them under the same tool set with Xray for JIRA, and NUCIDA supports you to achieve that. If you like it, please give this video a thumbs up, subscribe to this channel, and click the bell. Never forget our upcoming sessions. If you have any questions or hints, please leave a comment. Our certified QA experts will reply in time, or even produce a separate video about your topic. Please also check out our other over 200 videos about software quality. Happy testing! See you next time.